Hello everybody. So today we're going to be doing the homework questions for parametric equations, and I'm going to put all the answers in one video instead of multiple videos. And the reason being is because YouTube said I reached my upload limit because there were so many videos. And so I'm going to just put them all in one. If you need the next question, just go forward and you go to the next one. All right. So I'm going to start with my first question. The wording is weird because they're math teachers and they don't speak English. I mean, I can't blame them because I don't speak English either. But as you can see here, eliminate the parameter to find a Cartesian equation of the curve. So I have x equals t squared, and I have y equals ln t. So what you do to get the Cartesian equation, you just isolate for t and you sub in, which is pretty simple, I would say. Right, and then you sub it in, which will equal. So if I go zoom in here, and this will equal my right. The other way you could do it is you could do it from here. So you can say y equals I don't know why I'm rewriting that, but you could say e to the y equals my t, right? And what you can do here is you can sub that into there. So now I'll have x equals e to the y to the 2. And so you can actually go from here to here. So these are like the same thing. And so what you can do is you can see here, I'll do square root of x equals my e to the y, and then ln. I don't know why the lines are not smoothed out, but yeah. So these are basically the same thing. It's just this is more acceptable because it's in terms of y equals mx plus b. But technically they're both right. Now they're asking for us to sketch a curve that indicates with an arrow the direction in which the curve is traced as. Okay, so before you curve this, you gotta see the domain of your function. And so here, for example, you can't ln a negative number. And to be honest, I remember that, but I'm just not too sure. So I'm gonna double check right now. Yeah, you can't ln a negative number or 0. So your t has to be bigger than 0. All right. Now also here your x, the domain for your x cannot be less than or x. Oh yeah, so x also has to be more than 0. And the reason being, well, one, x can't be a negative number because it's squared. And since t has to be more than 0, that means x can't be more than 0, because if t can't be 0, how else are you going to get 0 for x? And so you got to keep this part in mind. This is probably the most important part, because when we go here and we want to graph it, what we'll say is we'll say t, we'll say our x, and we'll say our y. And what we'll do is we'll choose coordinates. And so since our t can't be 0, we'll have to start somewhere from that's not 0. And so you can choose 0.5, but I'm going to use whole numbers. So it's 1, 2, 3, and 4. And then x, you sub it in, that would be 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And then we'll go to our y. So ln of 1 is 0, I think. To be honest, I'm not sure. I'm pretty sure, yeah. Ln of 1 is 0. Ln of 2 is 0.69. And my ln of 3 is 1.09. And my ln of 4 is 1.386. And so if I go down here and I want to graph these are my coordinates. And so if I go here, as you can see, x at 1 is 0, so that's 1 point. X at 4, my y will be like a little bit here. And then my x at 9, so let's say this is 4, this is 1, 0, this is, well, you guys have it up here. I don't really have space to write all the small decimal changes, but let's say this is 9. My 9 is at 1. Let's say this is 1, and my other point is at 16, and this will be somewhere like up a little bit up here. And so you have it going something like that. I don't know why it's not smooth, don't ask. And so the direction is going is obviously this way. And so is there a way where it is stopped? Yes. So if your t was like, your t is between 0, t is bigger than 0 and bigger than 3, then obviously it will stop at 3. Oh, well, before 3, and it's not going to equal 3. And if it's equal, then you'll have it, stop at a certain place. So this starts at 1. Well, not 1. It starts at like a little bit more, like it can't be 0. So here it's asking, sketch the curve and indicate with an arrow the direction in which the curve is traced. So it doesn't say where it starts, but you guys get the point. And so that is solution number 1. All right, so this is question number 2. I haven't done this in practice, so I'm not sure of the solutions. So I might make mistakes right now, just keep that in mind. But I'm going to try to do my best and explain the whole thing. Okay, so match the graph of the parametric equations, x equals f of t, and y, g in terms of t, and AD with the parametric labels. Okay, so we have our x and y graphs. Okay, so this is our f of t, and this is our g of t. And this goes all the way down for this, this, and this. And these are like one part, and this is one part, and this is one part, and so on. All right. And so here, if we look at how can we match these? Well, let's see. Our x here, our x. So this is your t. I know it's a little bit blurry. Sorry about that. This is my x. So, my x is between 1 and 2. So 1, x is bigger than 1, and it's less than 2. All right. My y, on the other hand, is between 1 and negative 1. Right? And so this is what I got here. Now let's match these. So you see here, my y is actually at 2. And so that's not good. Because my y has to be more. You see here, negative 2. Here, my y is 1. And assuming this is negative 1 and this is 1. My x, this is my x, this is my y, by the way. My x is from 1 to 2. And so you can see my x from 1 to 2. And my y is negative 1 to 1. And so this is my graph A. All right. Now let's go to graph 2. Graph 2, our x is between, so my x, the domain, would be between negative 2 to 2. All right. This is my t. This is my x. This is 2. And this is my negative 2. Right? And so that's that. It also has 2 max, and it has 2 mins. And so that is my x. Also starts at 0, right? Starts at 0, and it ends at 0. Okay? And so that is my y characteristics. My y characteristics, by the way, I can... Oops. Keep this at 0. This is for this here. Okay? And so we'll also have, I'll write on this side since I'm running out of space here. Okay, so my y is between negative 2 and between 2. And it's the same thing. It starts at 0, ends at 0. However, has 3 max. That's my max. and has 3 mins, right? And so now, let's match this with something. This one here, my y is at 2 and -2, and my x is at 2 and -2. However, I don't see no max and mins here. My y has only one max, and my x has a infinite max. This is a straight line, that means infinite max. And so, well, not like literally infinite max, but you get the point. And my minimum for the y is infinite minimum, so it's definitely not that one. This one, my x, you see, my x is between 2 and -2, and my y, but also it's the same thing. I don't have my max and mins. But you see this one here, I have 1, 2, 3 max on the y. I have 1, 2, 3 mins on the y. I have 1, 2 max on the x. 1, 2 mins on the x. Also, as you can see here, I mean, you could also see here that at t1, it's 0, y is 0. And at x, at t1 here, my x is also 0. So you see at 0 and 0, they all pinpoint. Same thing here and same thing here. And so this matches. Okay. Now let's go to the next one. What do we have here? Let's write the characteristics. And so my y, the domain is 0 to 2, right? It has 1 max. Okay. And it intercepts the t twice. I mean, I don't think that matters as much here in our scenario. But what's my x? So I can see my x oscillating. So this is very important. When you see something oscillating, do point it out. Oscillating. I'm not sure if I spelled that right. I do math, not English. Okay. The domain, I have -2, x and 2, right? I have 1 max, 1 min, right? This is the min. That's the max. I have it at -2, and I have it at 2. This is where it oscillates in between. Technically, this is 2 max, 2 mins, and I have another one here. All right, so technically this is 2. All right, if you want to end this point, right? And so what does this match do? We only have these options. This is 1 max. Our y is 1 max. It has 2 mins. Our y has 2 mins, but this one has an infinite min, so that doesn't work. Here, what do we have? We have y has 2 mins, has 1 max. Our x has 2 max and 2 mins, and our x oscillates between 2, and you see it oscillates like sine, and so that tells us that this is our C. Okay, now let's look at this. This is obviously in this equation, but I'm trying to explain the math behind it. There's no point of just selecting if you don't understand it. Because sometimes maybe they'll just give you this and they'll give you 5 of these until you choose one. And so how do you find this? So our x has a infinite max. Infinite max. I don't know. You know what? We're gonna improvise. It has x infinite max at 2, right? Our x also has 1 min, and that is right here. It has another max, 2 max. Max at -2. So assuming this is -2 and this is 2. X is between -2 and 2, right? Okay, when x is positive, when x is positive, it's, so you see it's increasing at a constant speed, right? And so you see when x is positive, it increases at constant speed. It's increasing at constant speed. right? And so that's our characteristics for x here. Now, our characteristics for y, what do we have? So 1 max, and also our y plateaus between, let's say this is like 1, this is -1. Not between, before and after. So before, actually no, I can just say plateaus when y is less than -1, and when y is more than 1. Okay, that's where it plateaus, right? So 1 max, it plateaus 2 infinite mins. Okay, what else do we have? When y is at 2, when y is at, well, when y is at 2, your t is at 0. What characteristic can we say? I mean, we did say it's 1 max, right? 1 y, you can say, you see all these are little characteristics that you can catch. And so when y is less than 0, it's decreasing. When y is more than 0, it's increasing. Oh, sorry, it's the other way. Oops. It's the other way. Just don't forget, guys, this is the other way. All right, so now when we go here, let's see, our x characteristics. X has a infinite max at 2. So you see this is 2? Infinite max. All right, so that's one thing, infinite max. So if I actually here, oh my god, what happened here? Right, infinite max, and we have x is less than 2 here, and x is more than -2. X more than -2, x less than 2. And what else? What other characteristics do we write for x? When x is at positive, it's increasing at constant speed. And you can see it's the same thing here. It's increasing at constant speed, but here it's the same thing. It's consistent. The speed is not changing. So you could also read it as that, but I'm not sure how reliable that is, to be honest. I'm not sure how reliable that is. But this is accurate enough, I'd say. Because if you go to your y, it has 1 max and plateaus at y equals, when y is less than -1. So when y is less than -1, so when it's less than -1, is this -1? I'm not too sure. This graph is not as accurate, I'd say. But we do know that at -2, it's flat, right? Infinite. So did I write that somewhere? Plateaus. Oh, this is how I wrote it, because I calculated it. Did I do that right? Yeah, I did it the other way. So this -1 is supposed to be here, which I read wrong because it's supposed to be. But you get the point. So when at -2, it's infinite min. And you can see it's the same thing here, infinite min at -2. Right? And so from these alone, you could definitely tell that this is the only option. And you could easily also tell that this is the option. It's pretty accurate. And so that is your question too. It's a little bit longer, but it explains it in all detail. So I hope you guys found it useful. Hello guys, how y'all doing? So question 3. This is at a different time. That's why I have to salute. But for you guys, it'll be instant. So for this question 3, it's pretty simple. All you gotta do is look at the domains and use t as your common ground, since t is the same for both. And so what you'll say is, you could say here, well, I'll put it on the side so I could see it on a graph. My x. So if you look at x here, you know x has a maximum at 1, right? and x's domain is between 1 and 0. This is your x, right? This is your x right here. Between 1 and 0, so... And we're gonna say it's inclusive. It doesn't show any signs that it's not inclusive, like a hole or something. So, yeah, we're gonna keep it inclusive. And then we could say for y, our y is the same thing, but it's the opposite. And so, what do I mean by the opposite? Is that when x is 0, when x equals 0, our y equals 1, and vice versa, right? So what we can say is also when y equals 0, our x equals 1. How do we know this? Well, assuming this is t equals -1, and this is also t equals -1, then we can say when t is -1, our x is at 0 and our y is at 1, and we can use that, right? And when t is at 1, our y is at 1 and x is 0, and our x is at 0. And so we can use that. Let's say now we want to graph this. This is enough information, I would say. And so since both our y and x is between, is from 0 to 1, so we only have to make a graph from those two numbers. So mind my jaggly lines, right? Assuming this is 0 and this is 1. This is our x, of course, and this is our y, and assuming this is 1 as well. What we can say is here. So when x equals 0, our y equals 1. And so we'll have a point up here. And also, when y is 0, our x is 1, which is down here. And so this obviously connects something like this. But you're probably going to ask yourself, well, is it straight? Is it curved? Is it curved the other way? And what we can say, we can look at this, and we can look at other points. For example, we can estimate like when our t equals 0.5 or negative 0.5, then our y is at, well, what do we call this? This is so assuming this is where it's at, we can say our y equals 0.5, and if we're looking same here, we can say our x is also 0.5, and when t is 1, we also have y equals 0.5, and same with x. So we know they also meet at some point in the middle. So if I go like this, and somewhere here, that's the middle point, let's say, right? And that's how we got it. Now, the reason we would assume that this is a curved and it's not a straight line is because these two don't match. If they were to match, then their exact points of the way they turn or they connect to each other would be straight line across if they're the same. But since they're not the same, it tells us that it's probably curved. And the question is, how is the curve going? So we know that y starts at 1, right? We know y starts at 1, and it decreases as x is decreasing. And we can implement it. We can say, you know, it's somewhat like a straight line. It just has a little bit of curve to it, something like this. So if I were to delete this stuff and draw it properly, oh, I deleted the whole line. That's okay, I guess. Whoop, there you go. That's a better straight line. So we have a point here, and we can connect this point to right here. You can see I'm not putting arrows because in the graph here there is no arrows. This is the max they get to, right? And so what we can say is also for direction, this also doesn't say direction. It doesn't say you can go one way and not the other. And so this would be you can go up or down. And also it's not just arrows that indicate this, is because here you see here you're going backwards, and here you're going forwards. And same thing here, you're going backwards and you're going forwards. You see, if it was something, so if we were to have this part away and only this part, this is only going from -1 to 1, and it's not going the other way around. You see, our x is going from 0 to 1, and this portion is going from 0 to 1. But in this portion, if this wasn't here, then you would not be able to go from 1 to 0. And that's the same thing for our y. And that's why we're able to go from 0 to 1, but also from 1 to 0. And same thing, upwards and downwards. And that is how we know. The first thing is these are finite. So then they don't have arrows at the end, at the tips. And that tells us that these stop at our 1s. And also we know that we can go backwards and forwards because our y can go from 1 to 0 and from 0 to 1. The same thing as our x. And so this is the graph in that direction you'd get. All right, so question number 1, right under for calculus parametric curve. This one's pretty straightforward. We're looking for a tangent line which equals E equals mx plus b, right? Something like this. And since the equation is a tangent line of the curve, it's going to be like, you can say like a curve, and we're looking for like this tangent line, and this is supposed to be like close with it. I just drew it horribly. And it's always a straight line. That's the whole point of a tangent line, is a straight line. And so you have two conditions, one without eliminating t, and the other one is with eliminating t. And so the first way, how do we do it without eliminating t? So I'm gonna write my equations. Actually, I have enough space here. So the one without eliminating t is what you'll have to do is using the dy over dx of dy over dt all over dx over dt, because this one doesn't eliminate t, right? And so what we could do here is x, so dy over dt, we gotta derive this equation right here, so we'll get 2t, and our dx over dt will equal 1 over t when you derive it, and that would be our equation here. My beautiful lines are beautiful today. Now subbing these in here, right, what you'll get is 2t divided by 1 over t, which equals the same thing as 2t squared. Alright, so I just flipped and multiplied here. So now that you have this, so you have now dy over dx equals 2t. This is to find a slope. Now if I plug a number here, I'll find a slope for it, but the number I want is at this point. So what is t at these points? You can either substitute 1 into this equation or substitute 3 in this. So we can do 3 equals t squared plus 2. You take 2 to the other side. 3 minus 2 equals t squared. And now when we go here, we'll get root 1 equals t. And that's just 1 equals t. However, we have the plus and minus. But t can't be negative because of our ln, so this has to be 1. A positive 1 equals t, right? And so when we sub that in here to find our slope, because this is the derivative and it gives you a slope at a point, and so when I plug that in, what I'll get is 2. And that is my slope, m. And now how, okay, so we found the slope for this one. Now let's use the second method to find the slope, which is if you have x equals 1 plus ln t, and you have y equals t squared plus 2, and we're trying to find the slope here, what we could do is we can isolate for t. So what I could do here is I could do x minus 1 will leave me with ln t, and I can exponentiate, whatever the word is, which cancels out ln, so it will be e to the x minus 1 equals my t. Now what I could do is take this and sub it in here. So I have y equals e x minus 1 squared plus 2, right? So now what I can do is I can take this and derive it. So I can say dy over dx of e to the x minus 1 squared plus 2. Now when you derive, this 2 goes to 0, right? and this 2 comes down, so what we'll get is 2. Then we'll do brackets e to the x minus 1, and then you multiply that by the derivative of this. The derivative of this is just 1, right? And so what this will equal is 2 e to the x minus 1. And now you see we've eliminated t. T is not in the equation. Now we want to find the slope at some point. So we want to find dy dx at some point. And that point for us would be 1, right? And so what we do is 2, because the point is up here. And so what we'll do is we'll plug in 1, which will be e to the 0. And that will equal 2, which is the same. And that is your slope m. Now how do you find an equation? You'll do y1 minus y0 equals m x1 minus x0. That's how you can find your slope if you have a point. And so our y minus, my first y is 3 equals my slope, and then my x is still the same, minus the x I have, right? And so when I rearrange this, what you'll get is y equals 2 multiplies into x, and then 2 multiplies into this becomes -2, and I take 3 to the other side, plus 3, and this will simplify to 2x plus 1. You see this is a equation or function of a line, and so this would be your answer of 2 ways. Hey guys, we're doing question 2, which is the solved question here. So now what do we have? It says find the first derivative of a parametric, find the second derivative of a parametric, and tell us when is it concave up, what t value is it concave up. And so what we're going to do first is find our dy over dx. Of a parametric, it's your dy over dt divided by your dx over dt. And now if you want to find your dy over dt, what you can do is just derive this, which will give you, so we're deriving this, which will give you 2t plus 1, and my dx over dt is this one. So it's, right, now you go here and you sub them in. And this is the same thing as saying, and so what this is 1 plus. Now if I want to find, this is my first derivative, if I want to find my second derivative, you'll have to derive your first derivative again, and then divide the whole thing by your dx over dt. And so let's derive this one more time. My 1 will go to 0. I'm going to rewrite this like that. My 1 will go to 0. Now I got to derive this part. The derivative of this is negative 2t to the -2. Then you multiply by the derivative of the inside, which is 2. So this actually looks like, so I applied the square to the thing, and now what this will look like is 1 over, right, now you gotta take this and you sub it in here, so all over my dx over dt, which was my 2t. Now what this actually looks like times 1 over 2t. So if you do the math here, that's what it looks like. Now, when is it concave up? We know when your second derivative is more than 0, it's up, and when your second derivative is less than 0, it's down. Just concave up, concave down. And so that means this has to be more than 0 for it to be, so I shall do it down here. So -1 over 4t cubed has to be more than 0 to be concave up. Now, because we have this negative at the front, any positive number that t is, and this is cubed, so if you put any positive, if you put any negative number, you get negative. If you put any positive, you get positive. And so whenever t is positive, this number will result in a negative. right? That is issue number 1. Issue number 2, t cannot be 0 because you can't divide by 0. And so when can this number be positive? Is when t is negative, then it will equal any negative number you'll put here, you'll get back a negative number. And negative times a negative gives you a positive, and that's what turns this whole number into a positive. So when t is less than 0, you'll have a con up. Alright guys, so now we're doing question number 3. And so what question number 3 says is, at what points of the curve is this the tangent line? Does the tangent line have a slope of 0.5? So first, if you want to find a tangent line, you need a derivative, which gives you the slope, right? So let's get the derivative of this. Right, this is your equation. You do have to memorize this equation. It's not given. So my dy over my dt, is 3t to the 2, and my dx over dt gives me 6t, right? My plus 1 and minus 1 go to 0 when you derive. So now we gotta plug this in here. So we get 3t squared all over 6t. And this equals my dy over dx. Now this can simplify. 3 divided by 6. To be honest with y'all, I'm a little bit rusty today, but that simplifies to 1 over 2. So, and then my 1t cancels out, this t cancels out the top. So now what we get is t over 2 equals my dy over dx. Now they're asking, one is at what are they asking? At what points on the curve does the tangent line have a slope of 0.5? So if we do t equals 2 equals 0.5, that will give us the answer, right? So t equals 0.5 times 2. And t equals 1. But we're not done yet, because this only gives us t, not the point. So what we can do is you can plug t in here and find your points. So since our t is 1, that's an easy number. So this is x equals 4. We plug 1 here, and that will give us 1 times 3 is 3, plus 1 is 4, and at y, 1 cubed is 1 minus, so it's 0. So at 4 and 0, slope is 0.5. Alright, hello guys, so we're gonna do the last question. This one is actually, is it one of the hardest? I wouldn't say. It's probably a medium level. It's not too spicy, because it starts with a given equation. And so my given equation here is, I'll pop it up on my computer and I'll write it out here. So my given equation is, so they're asking here for a exact length of the curve. And so the formula for that is L equals the integral from B, that looks ugly, from alpha to B, the square root of your dx over dt squared plus your dy over your dt squared, square root that whole thing. All right, so the first thing you want to do is find your dy over dt, and that was going to be 6t squared. Yeah, and our second is 3t, so dx over dt, which is 60. Now you gotta plug those in here. And so when we plug those in, what we'll get is the integral of b and alpha, and the square root of my 6t squared plus my 6t squared squared. Right? Now what we can do here, I'm just going to rewrite the integral. I'm going to rewrite it a couple times actually. And what we can do here, so I'm going to expand. What happens here, this becomes 36 t squared plus 36 t cubed. And now what I could do is I could pull out a 36t. So I'll write in 2 steps. Right? And so this is what we have. And what I could do here is I could pull out a 36t squared, which becomes 36t squared. And then when you pull it out, it multiplies. And so what we'll get is 1 plus 36t squared here. Right? So I pulled out. So this became 36t squared, 1 plus 36t squared. And I actually pulled out a 36t, so there wouldn't be a 36 here. That's my mistake. Because I pulled out a 36 from both sides, so that's what it would leave me with. Right? And now what I can do is after I take the square root here, don't forget your dt. After I take the square root here, what happens, what I'll get is 6 t, right? And then I'll get 1 plus t squared here, right? Now the question is, how can I solve for this? How can I integrate this? This is a simple u sub. So you can make your t squared, your du becomes 2t dt. And now what we can do is I can divide this by 2, right? And so what I'll get is du over 2 equals t dt. The reason I did that, you'll watch, because 6 goes out. So I can do 6. And I can write beautifully. That would be nice. And this would be b. 6 came out. Now I have t left. I have the square root of u du over 2. But you see this t right here. This, so here, let me highlight. These two are together. So this t actually goes out. Right? And now if I rewrite this, what I'll get, this 1 over 2 also goes out. So what we'll get is 3 beta integral alpha, the square root of u du. Right? Now this is a simple integral. This is u to the -1. So here, let's rewrite this. Sorry, not -1, 1 over 2. Right? And so when you integrate a 1 over 2, you add, and then you divide by whatever you're adding. So 3. This one, when you add this, so we're actually taking bounds now. So this will be u 3 over 2, and then you divide by 3 over 2, but then we flip and multiply. Make it look nice, so it doesn't look ugly. That's really the purpose. You can keep at the bottom, like, I mean, look at that. That looks horrible. So now what we're taking is the bounds from b to a. And the question is, don't forget to resub your 1 plus t, or we can put this in terms of this. So what we can say, we can sub in 0 in this equation. So we'll get u equals 1 plus 0 squared, which is u equals 1. That's our first. And this is less than or equals to u, less than or equals to. And then we have 1. 1 squared plus 1 is 2. And these are our bounds. So now, if I resub this in here, and this would be from 1 to 2. Yep, this would be from 1 to 2. So let's do the math. And this would be 2 minus right? This is what we get. So what we get here, I'm just gonna rewrite this. This actually is, if I can remember it correctly, you know what, I can't. But we know this goes 1, and this is just minus 2 over 3. So I can pop out my calculator, and I'll do 2 to the power of 2 over 3. Or, sorry, that's 3 over 2. 2 to the power of 3 over 2 is some decimal number, so I'm glad I didn't find out. Times 2 over 3. This gives us 1.88 minus 2 over 3. Okay? So we get 3, 1.218951416. And we multiply it by 3, we will get 3.656854249. Now, what was the question? The question is, find the exact length of the R curve, and this is our exact length. Thank yous.